Hi, I will be talking about semiconducting polymeric field based on cornstarch for their application in triboelectric nanogenerator. Energy harvesting of the TENG refers to the process of skipping sustainable energy from mechanical energy. This using electrostatic charge created in the surface of two dissimilar materials. When they are brought into physical contact, it induces triboelectric charge that it creates a potential drop, which can drive electron flow between two electrodes. When I would talk of electrodes, I refer to two conductors, and between both we have a dielectric field. Our objective was obtaining a semiconductor polymeric field of cornstarch with carbon quantum dots. These create in a green way. The purpose of our polymeric field was used as electrode in a vertical contact tank. Well, our methodology was, for the first part, to create the polymeric field. We use cornstarch, sucrose, and sodium chloride. The sucrose we use for help us to create a flexible and transparent film, and the sodium chloride it helps us to with the conductivity of our film. The film was dried in an oven at 40 degrees for 38 hours, and for the system, the synthesis of our carbon quantum dots, it was prepared from the colloidal method using alcohol for obtaining our quantum dots. We use atom power and sodium hydroxide for this. And finally, the film we got 3 centimeters and doped with the dissolution of carbon quantum dots in alcohol. In the figure 2, we have this material. For the letter A, we have the semiconductor polymeric film based on cornstarch. The letter B, we have our carbon quantum dots in alcohol, and we can see the fluorescence with ultraviolet lamp. For the letter C, we have the film dot with our carbon quantum dots, and the letter D, we have the system that we create for this. We have the semiconductor polymer film, and between this material, we use PDMS as a dielectric film. For the result of this, the fifth part, we want to corroborate that our quantum dots were functional because we changed the solvent. Usually it's water, but we had to change from alcohol because our film are water soluble, so we couldn't use these nanomaterials in water. When we change the solvent of our nanomaterials, usually the nanoparticles agglomerate. But we did UV spectroscopy, and we have the same curve as the literature. We have the transition, the 2080 nanometers for aromatic groups, and the 3015 nanometers with CO group. We have these curves of the figure 3. And we also did other study. We did IR spectroscopy to know our functional groups in carbon quantum dots, and we have the same functional groups as in literature. And we have the figure 4, where it shows all the functional groups that it have our carbon quantum dots. And it has sense because all be of organic and it was too important for us. The last, we have a IR spectroscopy from our films. We did two. We have two in the figure 5. The red one is a film, the film with cornstarch, and the second one, the black, it's of the cornstarch, but it has the sodium chloride. And we can see the difference between the film without sodium and without carbon quantum dots are same as the film without it, because they are share the same group on functional groups, and it's too beautiful to see that. Finally, we have to know the output of our films. We measure with a TENG. The film we can see in the figure 6, in the film without, just with cornstarch, we have 2 volts. The film with sodium chloride, we have this 8 volt with 4 volts, but we can see something beautiful for the yellow one. It's the film with sodium chloride and the carbon quantum dots. Our conclusion from this work was that we want to follow the green chemistry to create this material. We want to change the metallic conductors of vertical contact to biodegradable films to really create green energy from the tank. Well, for this work, we use all the synthesis when using this green chemistry. We could see that if we use carbon quantum dots in other solvent as an alcohol, it works. It works too well. And we did 5 different concentrations. We use 10, 5, 10, 20, 50, and 100 microliters of carbon quantum dot into our field, but it could see that the better output using a tank was with the concentration of 15 microliters of carbon quantum dot. And that's it. Thank you.